Now we're back. Could you unmute your microphone, please, and let me know?
I'm back.
Okay. We have others back too.
I'm back.
Okay. I don't know if you saw, but I think in module 2, you should see a whole new revision. You should see a whole new revision inside the references folder. So, and revision 2 essentially, I included some of the same diagrams from our textbooks. So we talked about waterfall and how we had separate phases or stages, right? And that you couldn't start the next phase until this one was done. And so if you think about how a waterfall works, there's a certain amount of water and it flows down onto the next rock, and then it's a batch-like process, right? So traditional waterfall is really sort of primitive and rigid. We're a little more intentional about calling out the trade-offs, right? What's good about it, what's bad about it. And some of this is a repeat of what you learned in the first module, but there's usually a little more depth, right? Sashimi essentials. So it's also known as the waterfall with overlapping phases. And then if you said, okay, I have sashimi that keeps repeating in cycles, that would be incremental or incremental sashimi. That's a tongue twister. The limits and benefits, right? So if you have strong coders who are getting ready to start the only thing to remember is that sometimes when you're stepping ahead into new phases while the previous phase is being completed, sometimes you find out, oh, you got to go back and change some things. Oh, then we got to go back to design and change some things. So that's one of the disadvantages or downsides, cons of a sashimi waterfall. So modifications become obvious, and you have a lot of code overhauls. Now, you could argue that if you have more of that up front, you don't have as much once you deliver the finished product. Incremental essentials. So incremental is when you're handling things like waterfall, but you're overlapping the successive development cycles for each new version that's coming out. So you're overlaying or incrementing the version development. So as you're finishing up version 1, you're already planning what you're doing with version 2. You're already designing and implementing version 2, right? And this is a very common convention, especially among traditional software engineers. Pros and cons, yeah, it's a complex environment. And there is a good bit more documentation with this approach for obvious reasons. Tracking changes and increment phases can be quite complex. So change control is a challenge in this kind of environment. Can everybody understand that just by looking? Does everybody know what we mean by version control? Have you heard the term version control before? Or change management? Is everyone familiar with GitHub? How you can change settings and then like push out new versions or restrict versions, that kind of thing?
Well,
Yeah.
Okay. So that's those are the tools of version control. And so when you're working this kind of scenario in a coding shop, that's quite a challenge. The combined, sashimi incremental, right? So it's incremental, but it's also sashimi. I don't think that's any less complicated. In fact, sashimi is more complicated in terms of the possibility to revert back to a previous stage. And when you have multiple versions of that going on top of it, this is like the Mount Everest of complexity here. The V model. So in your textbook, it talks about the V model, and essentially it is the classic waterfall model, except that half of the stages engage process to break a solution down into smaller and more granular components. And then there's an inflection point until you implement. And then after that, the process is to engage in larger stages to integrate the components. And we talk about each person demonstrating their prototypes. So when you're first developing, if you're using a plan and document model and you're in a team, it's common for the team members to have to demonstrate each of their separate prototypes, and these are components. So they're taking an integrated solution and breaking it down into its separate components. That's the decomposition phase, right? And then when you get ready to put it all together and implement it as an integrated solution, what you're doing is folding those components together. And that's a different set of tasks and challenges. So the V model sort of captures this natural process where, okay, in the first part of it, everybody's sort of everybody soldiers on to get their own stuff done, to get their own components. And once everybody's ready and you can start combining them, there's this integration. There's a separate integration process. And they show that when you're implementing, you're folding the components together, and then you're testing to see if they work together. Then you're verifying and validating what? The original requirements. Now, here's a crazy thought. Did you know that after you combine components and you're integrating them, sometimes the original separate components work differently? Have you ever seen something like that happen? I've seen it. I mean, here are separate prototypes and they all work fine. Then you combine them and it's like, okay, something's different and this doesn't work anymore. Have you ever heard of the phrase about, yeah, we fixed this, but now we broke something else? If you've ever heard that kind of sentiment expressed with applications or operating system development, what you find out is that that's what they're talking about. A lot of times when they're bug fixing, they're working on a specific component, and then when they implement or integrate those components again and start testing, they have to make sure that the original design is honored and that the requirements still work the way they do. And sometimes they find out, sometimes they have to rush it out the door. So a great example of this is if you have a Microsoft Windows update and it fixes one problem, but then it breaks something else, okay? Which gets back to the operation and maintenance piece. Any questions about the V model essentials?
No question.
Okay. So the emphasis is still to walk through the same stages, but there's a different focus working up to the midpoint and then after the midpoint. SDLC essentials. So yeah, you have the classic stages for every, we said there were 5 stages present in all software engineering models. And in the planning and document models, you actually see 6. Have you noticed that? Has anyone noticed that? Does anyone remember me saying that you have 5 stages of development present in every single model, but they may present differently depending on the type of model? Everybody remember
I
that?
think so, yeah.
Okay, so I want to talk about that a minute, because I want everybody to understand what I'm talking about. Okay, does everybody see this? Requirements analysis and specification. Now let's go to this. Okay, here, that's requirements, all right? Now let's go to, wait a minute, are these, oh, this is the same. Let's pull this out so it's separate. Second stage, architectural design. Okay, let's go back. Wait a minute. Hold up. Second phase is what? Design. Well, so far, things are tracking pretty much the same, right? All right, let's go back here. Implementation and integration, right? Implementation and verification. Nope, that's verification. So implementation and integration is the same thing. Verification is the same thing, right? Okay. After that, deployment and maintenance. So I guess you could say that maintenance, okay, I'm going to tell you this from a personal perspective. When you deploy a solution, you have to verify it's working. So I consider deployment and verification to be the same kind of thing. And for the sake of clarity, maybe I should include that somewhere in here. But basically, deployment and verification should be part of the same process. I don't know of anybody that puts out a new application and they don't work some kind of checks, quality checks and assurance. Okay, is everything working like it's supposed to? Does that make sense?
Yeah.
Yeah. So you can verify before you deploy, but you're certainly going to verify after you deploy. So verification and deployment, I think, really kind of go hand in hand. Yeah, so maybe just to help clarify, we should tweak this module 1 understanding just a little bit. The planning and document models include, I mean, at least the textbook author includes deployment and maintenance as separate phases. And yeah, I think if it was done properly, you would verify the function of your beta product before you deploy it, and then after you deploy it, you would assess its performance, which is basically just like phase 2 of verification. The one thing you don't want to do is roll it out and then leave and say, call us if you have any problems. That's just a bad way to go. And I hope that makes sense. SDLC, it is by far the most tedious and expensive of all of the predictive SE models. And it's often commonly required by government. So you can have government agencies that say, we're going to use SDLC because we have regulatory requirements to consider, and we're going to do this right, and we're going to define how it works up front, and we're going to document everything because, you know, if it comes back to haunt us, we're going to cover our assets, cover your assets, so they don't get in trouble, right? So essentially, but this is cyclical, right? This kind of looks like spiral. So we'll talk about the difference between spiral and SDLC in a moment. SDLC is essentially waterfall. It's just a cycle. It just goes over and over and over again. And 6 1/2 does the other. If you start a second cycle of requirements, design, implementation, verification, and so on, you have this, right? You have this going on where you're starting over again, except that there's no overlap. There is no overlap. Okay? So this picture works the same as this picture in terms of process, except that you completely finish a version before you start the next one. Does that make sense? You're not
Yeah,
worried about the
it
next
does.
version. Yeah. There is no budget to start the second version and the third version halfway through the design process for the, I mean, if you have money coming out of your ears, you're a Microsoft or an Amazon, you can work like that, but some solutions just, the customer just can't afford that kind of thing. Gantt charts and PERT charts are one of those things that are often government requirements. And because each of these phases are broken down into sub phases, people love their flow charts and their deliverables. And so when you're looking at, we'll go into this in more detail, but when it comes to the requirements and design, UML is one way of capturing design criteria, both high level and low level. So all of that adds to cost, right? But then later on, when something blows up and a congressional committee wants to know what were the standards used to design this system, out come the charts, out come the high level and low level design UML. And then the subject matter experts have to like dumb it down for the congressmen and women, right? So this is kind of a necessary evil of SDLC. So you see here, acceptance testing. Acceptance testing is when you verify after deployment. So you verify it's working, then somebody verifies that this is what we wanted, then it's deployed, and then people sign off on the completed deliverable, right? Okay, the solution has been delivered. Yeah, I'm not so sure how much of this is part of the process. I know it's in there in the mix, but migrations and sophisticated bug reporting and resolution procedures. So the deployment and maintenance phase, there's a lot of moving parts there. And once again, just because you verify its function after you deploy it, it's important to do testing to see if it's actually delivering what it's supposed to do. And if you don't, then you're gonna have a lot more maintenance to take care of. Eventually, new hardware and operating system capabilities become the motivation for tiresome and expensive software updates and version releases as old technology is retired. So this is more of a personal observation from me, but after being in industry for 25 years, I've seen a lot of versions change just because, I don't know, the Windows GUI changed. And it's like, we're not using Windows XP anymore. We have a start button and it works differently, and we can work off of the Metro interface, and that means we can have apps here instead of like in separate folders. You'd be surprised at what drives this. When you have cybersecurity interests in the mix, right? SDLC tends to be a safe way to proceed because with all that extra documentation and careful implementation, you can go back with greater confidence to see, why something went boom. But here it says process review and disposal are often overlooked in SDLC, both in terms of the application code and in terms of customer data that is processed and stored by the software. Has anyone ever seen in your C drive a folder that says old Windows, or it's an old directory from an old version of Windows? Has anyone ever seen something like that? Yes, no, maybe?
I don't recall seeing that before.
Okay. Well, that's another aspect of version control, is that oftentimes when new versions come out, one thing they may not include is deprecation or deletion of old directories and old versions, right? Now, that concludes our review of predictive models, right? So up to this point, we've been talking about predictive models. This is chapter 17 of your, or it's section 1.2. So what we're going to do now is pick up as much of the iterative as we can. Has anyone had a chance to click on these links? So I made some things easy for you in terms of access to this stuff if you haven't reviewed it yet, right? So this is the Ariane 5 launch that they referred to before. Right? Just another view of it. Some of the previous links didn't work, so I revised that with our new version. Let's take a very short break and then we'll start with our agile, okay?
Okay. I'm here as well.
Thank you for coming back. So we can get into the next section in chapter 18, I think, of Rod Stevens. His iterative models, he takes up spiral, and you would think that spiral is like SDLC because it goes round and round and round, except that spiral has 6 stages, right? And no, I'm sorry. SDLC has 6 stages. Spiral has 4, right? And the 4 stages are objectives and constraints, identify and evaluate alternatives to improve outcomes and risks, right? Develop and verify the prototype, and then plan the next round. So it's cyclical, but there's a shorter or abbreviated number of phases in each cycle. So spiral added iterations, right, to the terminology. So the first time you work through those 4 stages, that's the first iteration, then you do it again, second iteration, third iteration, and so on. Customer is involved more before delivery of a complete result. So there are fewer failures in the final product. There is better track of progress and risk management incorporated in there. In contrast to the waterfall, There's better cost and schedule estimates. And you refine along the way with each iteration. So, but long cycles can be a problem, and customer needs and interests change along the way. We've already talked about scope creep. So one thing that happens here, you see in this diagram, after they determine the objectives, the alternatives, and constraints, they evaluate the alternatives, identify and resolve risks, and build a prototype. And they use the prototype to perform simulations and model problems. They fix the problems and produce a result, and then they plan the next iteration. So it's a simpler cycle to work through, and every time you do this, it's prototype 1, prototype 2, prototype 3. And even though it's simpler than waterfall, extra cycles can take longer to produce a final working result. So all the prototypes can be close to the real thing, but not a real working model. So some of the components are working in prototype 2, and then more of the components are working in prototype 1. More of the components are working in prototype 2. By the time you get to prototype 3, it's 6 months later, and so you're almost there yet, but you're not quite ready for prime time because there's still some components that aren't working. And the end result is that the cost for spiral can often climb higher than waterfall, but not as much as SDLC. SDLC takes the cake when it comes to project cost, right? So this kind of model, I would say one of the biggest challenges is keeping scope creep to a minimum, because the users with each cycle, they're like, okay, well now let's add this. And you're like, no, we're just trying to get the original model, the original concept better. Good, better, best. That's the goal. Not a different, hey, this is our solution version 2.0. No, that would be a whole different development process, right? But it's easy for people to get confused and they keep adding. I guess that makes sense, doesn't it? Any questions about spiral before we move on to RUP? So RUP has a different name, one you may have heard before. Has anyone ever heard of the term case tools, case development tools?
Sounds familiar.
Yeah, it is. It was a big thing. For a time, it was all the rage. And I'll tell you who the champion was. IBM. Computer aided software engineering. So they thought, okay, why don't we provide some really slick tools to develop the application, and we'll call it computer aided software engineering. And essentially what they did was they provided additional resources. The formal name for this is RUP. So the process is best represented by a matrix of 4 phases. So in spiral, you have 4 stages that recycle. In RUP, you have 4 stages across the top with disciplines. And then requirements, the engineering requirements across the bottom, okay? So the phases of RUP include inception. And one thing about computer-aided software design, IBM is all about supporting the business environment. So they'll get all sorts of input from users, and then they'll process user requests for features and like almost automatically generate UML code right? So when they talk about computer aided software engineering, they're talking about giving people the tools to kind of give them an easy button in inception. So the business case for a solution, what they want to do is explain and describe why are we doing this solution in the first place? How is it going to help our business? And ultimately with inception, it has to tie back to that. And then of course, it automates determination of schedule, budget, risk assessment, right? So has anyone ever heard of the term workflow management?
I have.
Right. So if you take workflow management, and you can get software that does this, right? Any project, not just software development, any kind of business process. There are integrated software solutions to help streamline, help make more efficient, simple things like a purchase decision. How many of you have been involved in a purchase decision at the University of the Virgin Islands? Anyone? Like work study students? Essentially what you have to do is get approvals at different levels before the thing can move forward. And that's not just true at the university, that's true at a lot of government agencies. It's true in a lot of businesses. So this concept of workflow management is a way of providing the screens and the buttons to automate the process. So here's an example of this, right? I want to show this to you. Can everybody see this?
Yeah, we can see it.
Okay, so we just went through this, didn't we? Well, unless you registered on the web before and you didn't have to make any changes. But a lot of students waited until after the holidays and they added their courses. So what I have to do is take this PDF and then fill it out. And then I get to the place where I have to sign off on it if I'm the instructor for that course, which means I can use this feature, right? But the simple truth is I logged in on my system. I have a digital identity already, so I could integrate my digital identity so that my login is proof of my identity. And essentially, when I fill this out and I click finished, guess what it does automatically? Go ahead, guess. It's like a magic form. The form just goes to where? The registrar, right? Unless the student involved, there's a lookup, right? So the student ID is put in here, and what happens is that as soon as you click this button, the student ID is referenced, and if the added course or if the course change involves an overload, then instead of going to the registrar, the system is smart enough to know, okay, I got to get a dean's signature to approve an overload. Now, in some of the semesters where you follow the computer science paradigm, you have to enroll in 17 credit hours or more. Has anyone experienced that? Has anyone ever done more than 16 and a half? Yes, no, maybe?
I think yeah,
I
I think
have.
freshman year.
Right. So if this is finished and you click, okay, I'm done, it goes to the dean first. The dean goes, oh yeah, well, what do I have to do? I have to look at what? I have to look at the student, then I have to reference their registration, then I want to look at their GPA, then I want to make a decision as an administrator, okay, is this like loaded dynamite? Are they going to implode if they have an overload? Or is this really part of the paradigm and they're doing, they're trucking along and they're doing okay? A student has to have a cumulative GPA of 3.0. And if they don't, they have to get approval from the dean, okay? So there's all these conditions that apply. The point is that we can use workflow solutions, workflow management systems in very large enterprises. And why am I taking the time to share this with you? Well, one of your solutions could be something that changes UVI and their enrollment process for years to come. I'm just planting a seed here, but let's say that you decided you were going to take the idea behind RUP, which is CASE, which is computer aided software engineering. And I'm oversimplifying, yes. So what computer aided software engineering does is it provides the same kind of workflow management tools for a coding team so that their interaction and their process is automated in the same manner that a workflow solution for the University of the Virgin Islands. I mean, am I making sense? Is this clicking? We take a common process. I mean, think about it. If everybody was doing their own separate components, and then we had to have a committee, and we reviewed each of our components, and then you demonstrated each of your components, and then we critiqued and evaluated your component, your prototype, right? And then afterwards, we have to integrate them, right? And then we have to make sure that we can demonstrate the object-oriented programming criteria and attributes, right? Because we're dealing with modular code and you know, reusable objects, right? The point is that you have to have all this quality assurance, and there's process, and somebody has to say, okay, I can validate that your widget plays nice with my widget. When you send your data from your prototype to my prototype, when I'm integrating that part of it during integration and implementation, does everybody understand what I'm saying? We could each turn you into Adobe PDF coders, and we could ask one of the teams in this course, please, pretty please, could you develop an integrated workflow solution that would make this seamless? All you do is fill it out, right? Heck, it can even be voice activated. You click on here, there's a little microphone, you speak the student's name, and boom, there's the ID number with their name, so you can verify. A little window pops up, right? Do you have to fill out which semester it is, or is it pretty obvious that if we're in January of 2023, we're in spring of 2023? I'm just saying. Hello? Could there be a little calendar function that takes the system date and it goes, okay, we're talking about like now? Because if it's an add drop form, what are we implying by the add drop form? Oh, you woulda, coulda, shoulda web enrolled in the fall semester, but here we are when? In January, and we need to do what? Make a course change. So there's some logical thresholds that become met. Now, I know I'm getting pretty animated here, and it's been a long period. But what I want to impress upon you is how cool this is, how powerful this is, and then I'm going to flip this, okay? So here we go back to IBM. IBM came up with a series of workflow automation and computer-aided tools, right, to help smooth the process between inception, elaboration, where you create use cases, application architecture, prototypes, and then you build, right? The construction, the coding, the testing, the first release, and transition, deployment, and customer acceptance. Now, if you look at it, a lot of the same stages are in there. They're just called something different. Why? Because if IBM calls it inception, elaboration, construction, and transition, they can put a trademark on it and nobody else can use it. Nobody else can copycat. And why would they want to do that? Because if IBM gives you an easy button to make an entire team development process quick, fast, simple, and efficient, You better believe IBM is charging a mint for that. You want to talk about the most expensive software engineering model? By far, computer-aided software engineering. Now, SDLC may cost the most in terms of the overall resources required to complete a project. But as far as the model itself, if you choose CASE, you're paying IBM for RUP. It's owned by IBM. And they're all about business. International Business Machines is about business modeling. So what you're developing supports the business, only supports the business, right? Or you don't develop it. So yeah, it's planning and documentation is traditional in that sense, but it's planning and documentation on steroids with new and improved technology tools to, to automate your business modeling, your requirements, your analysis and design, your implementation, your testing, and your deployment, which sounds familiar, right? And what you see here is a table that shows you that in the inception phase, you're doing more business modeling and requirements. Does everybody see this? In the elaboration stage, you're doing a lot of business modeling, requirements, and analysis and design, right? And you're starting to do a little bit of implementation. By the time you get to construction, right? See what happens to business modeling and requirements? You're doing less requirements and less business modeling by the time you get to construction. But you're doing more analysis and design and more implementation process with your team. So this chart basically tracks the intensity of different tasks and processes, right? The different stages during the 4 key phases of the RUP lifecycle: inception, elaboration, construction, and transition. And yes, it is protected by intellectual property, copyrights, patents, trademarks, all that, right? So what are we saying? If you want to be an IBM case shop and you want to do SDLC, there's probably some modules to do SDLC explicitly. And yeah, you'll be trained how to do that within the context of inception, elaboration, construction, and transition because that's their product. But you'll still be doing this and you'll be doing it over and over and over again in the cycle. True to SDLC. The whole point being that you're going to sign on and then you're going to learn a whole new way of working together. And when the tools are gone because you didn't pay your renewal, IBM is going to laugh all the way to the bank because your developers are going to become dependent on all of those easy buttons. What am I saying? Workflow management becomes kind of like crack. When you have a system that works so well that you can just seamlessly register people without really having to do a lot of extra legwork, that's sexy. And people want more of that because they get to go home sooner every day. Every semester, every time we go through the crunch at the beginning of the semester, a lot of faculty are frustrated, a lot of students are frustrated. And why? Because we have a process that hasn't been automated with an enterprise integrated solution. And that whole concept of workflow management is what they actually use for a software engineering model, and they call it RUP. It'll cost you $100,000 to implement RUP in a software engineering studio where solutions are developed. If you have a team of like 10 programmers, 10 software engineers, you can expect to pay 6 figures to get it started and tens of thousands of dollars every year to renew the license to use it. And that's just to do the workflow or the coding. Do you understand what I'm saying? Like everybody has easy buttons and they do their part and they click, and it helps. It even helps generate the code. Is everybody here familiar with JetBrains and how it helps you write the code? Do you know what I'm talking about? Hello?
I didn't hear the first part.
Is everyone familiar with JetBrains and that environment and how sexy it is because you start writing the code and it actually helps you write the code? Does everybody know what I'm talking about?
I know JetBrains, but not the part where it helps you write the code.
Okay. Well, there are some features and functionality there you can turn on, and it can make for programmers who are not as familiar, it's a crutch. And if you had that idea on steroids and you applied it to the entire software engineering team, what you'd have is RUP. You'd have automated testing features built in, right? All that. Very expensive. People love it. They love computer-aided software engineering, but boy, do you have to have a lot of money. And ultimately, you have to pass that on to the customer. So your applications and solutions you develop, you have to pay for the IBM stuff somehow, which means your solution has to be charged. You have to charge more for it in order to be able to pay for all that, right? So what environments use RUP? Well, big corporations, right? People with money. And that's really important, okay? I did want to talk about clean room for a minute, but we're at the very edge of our session. So let's do this. We'll finish up with clean room and project management principles because there's a big piece of planning and document that involves project management, and we need to introduce you to the Einstein of the business world, a man called Peter Drucker, and how he was like the Einstein of project management. And he's required reading in a lot of places like Stanford, right? The best business schools. And just an amazing man, but talked about the difference between leadership and management. And yeah, we'll talk about how the project part, strong project manager, every legacy, whether it's predictive or iterative, requires a strong project manager. And one of you will each take your turn being the strong project manager. You're going to have to mind certain things if you choose a traditional software engineering model to develop your solution. So that's what we'll cover. And there's some real gems in here. There's some real like workplace, life-changing kinds of concepts in here that have nothing to do with the actual coding itself or the coding environment, but it's about workflow process and how best to manage a large project. And I kind of get excited about that because that's where the strongest technology leaders evolve, the ones that develop those instincts. So we're going to touch on that on Thursday. So I look forward to our class on Thursday. Uh, Once again, congratulations for a strong first attempt of Module 1. This is a different animal, and you should be pleased. As we keep going, you'll get better and stronger at this, and then we'll get into teams and create some solutions.